Today we're going to be learning about exponents.
An exponent is just a way of writing long numbers in a shorter notation. We actually call this exponent notation. Exponents have two parts. They have the base. For us, the base is a 10. And they have the exponent. That's that little number that's written up here. Exponents are a way, like I said, of writing larger numbers, but they're based on multiplication. So this exponent is telling us to multiply 10, the base, 3 times. Let's see what that looks like. 10 times 10 times 10. You'll notice that I have 3 tens because the exponent was 3. Let's find the answer to this. I know that 10 times 10 would give me 100, and then 100 times 10 would give me 1,000. I was able to really quickly get those numbers because remember that multiplying by 10 is like adding an extra 0 to the number you already have. So 10 times 10, I'm just taking that 0 and adding it onto the 10, 100. 100 times 10 is just taking that 0 and adding it onto the 100. Now I have 1,000. So what I just figured out is that 10 to the third power, that's what I call this number in exponent notation, is equal to 1,000. Let's try another one. What about 10 to the fourth power? Remember that my base is 10, so that's telling me that's the number I'm going to multiply over and over again. And the exponent, the 4, tells me how many times to multiply it. So this is equal to 10 times 10 times 10 times 10. Now I'm going to do this in pieces, so I'm going to start with just the first part. 10 times 10 would give me 100. Then I've got 100 times 10, which would give me 1,000. Then I've got 1,000 times 10, which would give me 10,000. So I just figured out that 10 to the fourth power is equal to 10,000. Let's try one more. What about 10 to the sixth power? This means I have to multiply 10 6 times. So I've got 10 times 10 times 10 times 10 times 10 times 10. Okay, so let's do this in pieces. First part, 10 times 10, we know it's 100. 100 times 10, 1,000. 1,000 times 10, oh, the 10's already written there for me, 10,000. 10,000 times 10, I'm up to 100,000. And finally, 100,000 times 10 would give me 1 million. So you can see that 10 to the sixth power is equal to 1 million. And writing 10 to the sixth power is a whole lot easier than writing out this big giant number. It's important to remember that exponents tell us how many times to repeat the base. So remember when we were figuring out 10 to the 6th, we were doing 10 times 10 times 10 times 10 times 10 times 10. Be careful. Sometimes students think that a shortcut would be doing 10 times 6. Multiplying these two. I know that 10 times 6 would be 60. That's nowhere near the real answer of 1 million. These two numbers are very, very different. So be careful. Do not just try to multiply the base by the exponent. That will not give you an accurate answer. You might have noticed some patterns as we were figuring out some of these different exponents with a base of 10. I'm going to write down a few exponents that have a base of 10, and I want to see if you are noticing any patterns or shortcuts that might help us figure out the answers even faster. So 10 to the second power is equal to 100, 10 to the third is equal to 1,000, 10 to the fourth is equal to 10,000, 10 to the fifth is equal to 100,000, and 10 to the sixth is equal to 1 million. I'm sure you notice what's going on as these numbers advance down, but I want you to look really closely at the relationship between the exponent and the number of zeros that exist in the number. 10 to the second has a 2 as an exponent and 2 zeros in the solution or the product. 10 to the third has a 3 as an exponent and has 3 zeros in the product. 10 to the fourth has a 4 as an exponent and you guessed it, 4 zeros in the product. This works with any number that has a base of 10. So if I had a number like 10 to the 8th, it would take me a long time to do all that multiplication, but since I'm noticing patterns, I can take a slight shortcut here. I notice that all of my numbers that deal with exponents with a base of 10 start with 1, and this one is going to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go ahead and put in my commas, so count 3 from the back. 1, 2, 3, comma. 1, 2, 3, comma. And I don't need a third one. I just figured out that 10 to the 8th is equal to 100 million, a very large number. Now this pattern that we're noticing with the zeros and the exponents, this only works when we're dealing with bases of 10, but for today, that's what we're looking at. Now you know how to solve exponent problems that have a base of 10. You know how to use the patterns to help you, or just use multiplication. I would read this number as 10 to the 5th power. And if I figured it out, 1, 2, 3, 4, 5, the solution would be 100,000.
Ready for a little more challenging work with exponents? Next, we're going to be learning how to use exponents to write numbers in expanded form.
Let's say I have a number like this one, 2,347. Normally, if I was writing this in expanded form, I would break each of these into its different place values. So I might write 2,000 plus 300 plus 40 plus 7. If I wanted to use exponents to write this in expanded form, what I'll do instead is I'll take each of my numbers here and I'll represent them using exponents. So I'm writing a multiplication sentence for each of these pieces. So let's write 2,000 as an exponent. This would be the same as 2 times 10. And now when I choose my exponent, I just need to look at how many zeros are here. So since there are 3 zeros, this is like 2 times 10 to the third. Notice how I'm putting parentheses around it? That keeps this together and tells someone who is looking at this problem, do everything in the parentheses first. I'm still going to have my addition sign. Now I'm going to work on writing 300 as an exponent multiplication sentence. So I know it has to start with 3 because that's how I'm going to get the 3 at the beginning of my 300. And I'm going to multiply that by 10 to the, and there are 2 zeros here, so it'll be 10 to the second. I'll close my parentheses. I'm ready for my next addition sentence. And now I'm going to write 40 as an exponent multiplication sentence, I should say. So I'm going to do 4 times 10 to the, this time I only have the 1 0 here, so I'll only need a 1 as my exponent. And then finally, plus, and I'm kind of running out of space here, so I'm going to write it on the next line, 7 times 10 to the, wait a minute, there's no zeros here. So I'm going to do something that'll look kind of strange. I'm actually going to put a little 0 up here for the exponent because it says this will just be 7 times just 1, or 7 with no zeros. So this is the number sentence that I would write if I was trying to write 2,347 in expanded form using exponents. Let's write this number in expanded form using exponents. My number is 47,359. So I'm going to start with the 4. Remember that the 4 is actually worth 40,000 because it's in the thousands place. So I'm going to do 4 times 10 to the, and I want a number here that's going to be equal to that 10,000. This is going to have 1, 2, 3, 4 zeros. So 4 times 10 to the 4th will give me 40,000. I'm going to put that in parentheses, and that will represent my first number here, the 4. Next I have the 7. It's in the thousands place, so it's worth 7,000. So in order to represent that, using exponents and multiplication, I'm going to do 7 times 10 to the, and let's see, it needs 1, 2, 3 zeros behind it. So I'm going to put a 3 here. And if I multiplied this out, this would give me 7,000. My next number here is the 3. I'm going to do 3 times 10 to the, let's check, 1, 2 zeros behind it. Now I am running out of space, so I'm just going to go on to the next line for the final 2 numbers. We've got 50. I can get 50 by doing 5 times 10 to the, only needs 1 zero behind it. And finally we've got 9, and this one's always kind of strange. This is times 10 to the 0th power, which sounds odd, but it's because there are no zeros behind the 9. All I need to do to get that 9 is 9 times 1. And there we have 47,359 represented using expanded form with exponents. If it helps you, you can always write it in expanded form first, the regular expanded form. 40,000 plus 7,000 plus 300 plus 50 plus 9, and then change that into exponents if it's easier.